So this presentation is about ordered data and things that you can figure out by putting your data in an ordered list. It's all just, we imagine you starting out with just a bunch of numbers and just some way to get a handle on them. The first thing we're going to do is talk about sorting. And sorting is the act of listing data in a particular order, such as the largest to smallest or the smallest to the largest. So anyway, so that they are in order. The high is the largest number, largest numerical value of a data item, and we denote it by Q4. The Q will be explained in a few slides. The low is the lowest numerical value of a data item, and it is denoted by Q0. The range is the difference between the high and the low, and it is Q4 minus Q0. And so, all right, now, in addition to the high and low, which are at the highest value and the lowest value, we also talk about the median value, which we label as Q2. Just as 2 is between 0 and 4, the median is between Q0 and Q4. The median is the value of the data item that falls in the middle of the data set. Okay, there are an even number of items. If there are an even number of items, then the median is the average of those two middle items. Now, if there are n items, okay, the location of the median within the set is at n plus 1 divided by 2. Okay. Now, if n plus 1 divided by 2 is not an integer, just say it's like 5.5, then you'll have a data item number 5 and a data item number 6. Just average data item number 5 and data item number 6. And those will be, that average will be what we call the median. It will fall, its value will fall in the middle of the data set. Okay. And again, as said above, the median is denoted by Q2. We will explain that Q, I think, in this next slide. Because Q stands for quartile, and we have quartile is like cutting things into quarter, and that's where the 4 comes from. We put in the 0 at the bottom just sort of as a handy way to say, hey, we can name the lowest thing too at the same time. So the Q0 is the lowest, Q2 is in the middle, and Q4 is the highest value. Well, we've got gaps here. What about Q1? What about Q3? Well, Q1, as you might imagine, it's in the middle between the Q0 and the Q2. It's the median of the bottom half of the data set. And the Q3, okay, it falls between Q2 and Q4, and it's the median of the top half, okay, of the data set. And so Q0 is a smaller value than Q2, you know, and or Q1, and Q1 is a smaller value than Q2, and Q2 is a smaller value than Q3, and Q3 is a smaller value than Q4. It all makes sense. Okay, and so what I have here, this is some data I have. These numbers are in fact come from a program that I manage. I had every student come in, write down how many hours have you passed at this point. And as you see here, they're just not in any particular order. Over here, I've listed it from the lowest value, which is 45, right, to our highest value, which is 220. And so the 220, again, is our Q4. The lowest value is our Q0. And we find the other values by their positions. See here, I've got these in four more or less equal lines. The last line is a little bit off. If we want to find the middle, okay, the middle, okay, is going to be right here, right? Because that's the middle data item. I could count off and find it, but look at it, it's the middle data item. Which is right, this right here. Now the other bit is harder. Okay, well, because we're looking at the bottom half. Well, it turns out that this right here is exactly the middle of the bottom half, and that gives me my Q1. And this right here, right, this is exactly the middle value of the top half, and that gives me my Q3. Now, I have it all listed over here. Why? Because what I've done over here is I just, okay, taken that data unsorted, and that there are functions in Excel that will help us find all of these values on their own without putting it in order. But you know, putting it in order is just a very good thing to do, and it reveals a lot of stuff besides this. Now, once you have your values of Q1, Q0, Q1, Q2, Q3, and Q4 calculated, you can represent them graphically. Here we have the box and whiskers diagram, and you can see, hey, it's got box, it's got whiskers. Okay, this is from this example we just worked right here. This is the lowest value right here. Okay, and the highest value was 220. Well, this is right here. We've figured out the median value. Well, that falls right here, and then the middle of the bottom half falls right here, and the middle of the top half falls right here. What you want to notice is this is more clustered around the middle than it is towards the edges. This right here has the same number of data items in it as this right here does, but this is over a much shorter distance, as it were, and so these values are more spread out. Okay, this and this appears to be about the same, you know, more or less. This is not too much different than this right here, so it's sort of a balanced set. Okay, right here I have some data that's not quite as balanced. Okay, see, this has the same number of data items as here, so the values are more spread out over the top than they are over the bottom. This is a frequency distribution. These are test scores. I had 27 students take an exam. The one who made the lowest was 49. The one who made the highest was 100. I broke these up into a table. How many A's do I have? Well, I give A's to people who make above 90 or above. So I count from here to here. There are 14. How many B's? Well, people who make between 80 and an 89, they get a B. And so there are 3 of those in this class. C's, anything 70 and above, up to 79. There were 7 of those. There was one person who made a D at 160, and then there were 2 people who failed, and the total number of people, these numbers added up right here, was our 27. Okay, now you can look at the numbers and tell something, but if you put it in a bar graph, here a histogram. This isn't precisely a histogram, but I'm not going to grind my corn that fine in this lecture. Here in this bar graph, I've taken my A's, and I have above my A's made a rectangle, which is, you know, has a height equal to the number of items in my frequency table. I've done the same here. There were 3 items. If I had 3 B's, well, I've made this 3 high here. I had 7 C's, so I've made this 7 high. There was 1 D, well, so this is 1 high. There were 2 F's, so this is 2 high. So you can look at here and have a visual impact of, oh wow, a lot more A's than anything else. Okay. Then we talk about relative frequency. So the first half of this is all I've done is recopy our frequency table. For relative frequency, that's really what's going on in this column right here, this third column, where I've taken the total number, okay, the total, let's go back, the total number of data items, and have divided that into each of the frequency classes. And so we had 14 people made A's, so 14 out of 27, that was 0.5185, you know, about 52% of the class. We had 3 out of 27 make B's, that was like 11% of the class, 0.11, and so forth. In this manner, I just divide each class frequency by the whole, by the total. Okay. Now this column over here, it's sort of an old-fashioned thing, because we used to make pie charts using a protractor and a compass. These days I make a very nice pie chart using Excel. But what I want you to see is what to do here. We have 360 degrees around in a circle. Well, I take that 360 degrees and multiply it by the fraction of A's that I have. So 0.5185 times 360 will give me about 137 degrees. And so if I was measuring this with a protractor, I would have 187 degrees from here all around to here. Okay. And for, gosh, the B's, I would have 40 degrees from here through here, and so forth for each of these classes. Okay. But in terms of this graph here, which is called a pie chart, you can look at it and say, hey, I've got more A's than I have anything else combined. You know, very, very nice scores on this exam. Okay. This, okay, again, I've taken the same data and I'm making what's called a cumulative distribution. Okay. And so I have my class breaks here by just multiples of 10. And a cumulative frequency counts what happens up to that point. And so the 0 here says, oh, thank goodness nobody made less than a 10. The 0 here says, oh, thank goodness nobody made less than a 20. And so forth. Each of those, we don't have anything happening here until, oh, well, one person made less than 50. That person made a 49, as you recall. 3 people made below 60. 4 people made below 70. 10 people made below 80. And 13 people made below 90. And then here on this last one, the 100, since we only have 100 points possible, this class is a little different. It says 27 people made 100 or less. Okay. And so this, we mark this on what's called a cumulative frequency ogive. Okay. Pronounce that like you're French. And we mark it with x and y coordinates, the x being the cumulative frequency, the y being the cumulative frequency, and the x being these cut points. So right here, okay, this is like at 60, and it has a height 3, so this is at 60. Okay, and so what you can tell about using an ogive is that the steep segments are where things are happening. Okay,